So we are looking at 12.6, a section on scatter plots, correlation, and the regression line. So let's define a scatter plot. All right, a scatter plot is a collection of data points. So let us construct a scatter plot. Our table here, let's say we have years of education, or refer to our X values, X-axis. We have score on this prejudice test, refers to the y-axis, the y values. So we have 12 and 1, 5 and 7, 14 and 2, 13 and 3, 8 and 5, 10 and 4, 16 and 1, 11 and 2, 12 and 3, and then we have 4 and 10. So this is our table, and we'd like to make a scatter plot out of this. All right, so we should be able to do that. Years of education is our x-axis. All right, so these are x values. Looks like we go from smallest number looks to be 4, biggest one maybe about 16. So I'll go up to 16 there. 1, 2, 3, 4. This is 5, 6, 7, 8, 9. This is 10, 11, 12, 13, 14. This is 15, 16, 17, 18, 19, 20. Y-axis is the scores on the prejudice test. And it looks like our values go up to maybe 10. So 1, 2, 3, 4. This is 5, 6, 7, 8, 9. This here is 10. So now we just start putting our points. 12, 1. So this is 12 and 1. Maybe somewhere around there. All right. Next one is 5, 7. All right, so here is my 5, 7 around there. And we just continue 14 and 2, 13 and 3, 11, 13 and 3, 8 and 5, 5, 6, 7, 8, 10 and 4, 16 and 1, 11 and 2, 12 and 3, 4 and 10. All right, so this is a nice example of our scatter plot. Because once again, scatter plot is just a collection of points. As we can see here, we have a bunch of points, right? So that is our scatter plot. So a scatter plot can be used to determine whether two quantities are related. So here, is there a relationship between the years of education and the score on a prejudice test? Right, so that's the question. Is there a relationship between the years of education and the score on a prejudice test? So are these two related? So what do we see here? I'm noticing that the more education, the lower the scores on a prejudice test. Right? So I noticed that. More educated, the lower the score on the prejudice test. What else do we see here? How about people who don't have much education at all? People who don't have much education are getting higher scores on a prejudice test. Right, so this is what scatter plots are used for. If there is a clear relationship between the quantities they are said to be related. I'm sorry, they are said to be correlated. And this correlation is used to determine if there is a relationship and if so, the strength and direction of the relationship. Right? So if there's a clear relationship, we say that it's correlated. And this correlation is used to determine if there's a relationship and the strength and the direction of that relationship. So this measure used to describe the strength and direction of a relationship between variables is called the correlation coefficient. And it's designated by a lowercase r. So this measure that's used to describe the direction and strength of the relationship between the variables is called the correlation coefficient. So let's take a look at some examples here. Let's say that there is a perfect positive correlation. So we say that R is 1. What this would look like is a line or dots going upward, and it looks like you can connect them with a straight line. Our next one is a strong positive correlation where your R can be approximately 0.8. What that looks like, it almost looks like a perfect straight line. Points are pretty close to each other, still going upward, but we cannot connect them all to make one perfect line. All right, but they still, if you put one line there, they look like they're pretty close together. Then we have a moderate to weak positive correlation. This R would maybe be somewhere around 0.3. What we'll see here is that they're a little bit more spread apart. We see that the points are going upward, but now they're more spread apart. So the more they spread apart, the closer it gets to 0. So what if it was 0? This would be an example of no correlation at all. All right, what you'll notice here is that your dots are all over the place. This does not look like it's going upward, right? This looked like it was going up from left to right. From left to right going up, left to right going up. Here, left to right, I mean, there's no up. It looks like it's all over the place. So when it looks like it's all over the place, it's no correlation at all. 1 perfect going up. 0.8, it's pretty close to 1. Think about 80 cents. 80 cents is pretty close to $1. Points are pretty close going up. think about this as 30 cents, right? 30 cents is further away from $1, so they're a little bit more spread out. And 0 cents, I mean, no money at all. It's just all over the place. How about now we look at it going downward, right? Let's now look at a moderate to weak negative correlation. This R would be around negative 0.3. And this time it looks like it's going downward. When we view it from left to right, and we definitely see it's spread apart, but we can tell that it's going down, right? How about a strong negative correlation? Maybe something around negative 0.8. This time it looks closer together, but definitely going downward. And then how about one last one would be our perfect negative correlation, which is -1, and that's a perfect line going down. So what can we take from this, right? Well, we see that we go from 1 to 0, then we go from 0 to -1. So important note is that your correlation coefficient must be between -1 to 1. Right? So those are your only options, right? So you have -1, you have 0, 1. Only numbers in there. And what we notice is that a perfect positive correlation tells us that we can connect them all to make a perfect straight line, right? Negative perfect correlation, we connect them all to make a straight line. And as it starts going away from 1, they just start spreading out just a little more. And the further it is from 1, the more spread out it will be. This is important because, once again, we need to be able to look at our scatter plot and try to estimate what our correlation would be. Where does it fall? Is it closer to 1 or is it closer to -1? Right, so when we take a look at our example, the fact that it's going downward means it should be a negative. Now, these points aren't perfect. You can't connect them to make a straight line, but they are just a little spread apart. Right? So maybe it can be like a negative point. Maybe your R, right, can be like a negative 0.9 or a negative 0.8 or a negative 0.7 or a negative 0.6. All right, and I think those would be good estimates because they don't look too spread apart. They're not like this, right? They're not in the negative 0.3 where they're really spread out. I mean, they look like they're kind of close to each other. What we're going to do in the next video is we're actually going to calculate this correlation coefficient and see which one of these is our R?